world's best time to make a recording. Since I've got a cold, so you have to live with in a really hoarse voice. But the only way you can explain this is with a video and an audio explanation. So let me get through it. We've got a reaction, lead and lead oxide, reacting it with an acid to make lead sulfate and water, which doesn't sound exciting, except this is a really good redox reaction. It's got a nice voltage, reversible, so you can recharge. This used to be the mainstay battery for cars. One of these things, you could put up enough power to turn over an engine to start it, to run fans and radios. They're being replaced now with lithium because lead's a pollutant, and also lead's heavy. 1 gram of lithium can move a lot more electrons than 1 gram of lead because you have more atoms of lithium in a gram. But let's deal with this. This is still a prominent reaction, and it's a good chemical reaction. They've given you the overall reaction, and they also showed you how the electrons are produced, how they're oxidized. The lead reacts with the hydrogen sulfate to produce lead sulfate, some acid, and it releases some electrons. When it does so, and those electrons are used by the reduction reaction, the cathode, and that pull and push is provides you your power. And the question is, what's the reduction reaction? And that's a test. That's a good one for. Let's figure that out. We're going to have to produce an overall reaction. This is the reaction we're going to have to produce. And I'm not going to lead, and we're going to have some lead oxide. We're going to need some acid and hydrogen sulfate, and end up in the overall reaction producing some lead sulfate. It's interesting that the oxidation and the reduction both produce lead sulfate. Everything adds up to this, and let me make sure I got my coefficients right. It's exactly as it's written up there. You'll have plenty of room on the FRQ. They've got, the College Boards doesn't skimp with empty space to answer these questions, so you're never going to have to run out of paper. You know already that there's going to be this reaction. They give us the anode reaction. So we know the anode is going to end up having some lead, which is good. That takes care of the lead. It's also going to produce some hydrogen sulfate, so I'm writing the anode reaction right now. Here's one of the hydrogen sulfates, and the anode already produces 1 lead sulfate. And now I'm going to include the other stuff that they've gotten in this anode. The anode has some acid, but we don't see it in our final reaction, so we're going to have to cancel out this acid eventually. And these 2 electrons, which we know will cancel out with the reduction, which can accept the 2 electrons. This is the oxidation. Now, we're going to have to get the red, the reduction. And we know the reduction plus the oxidation produce the overall reaction. We've got 1 lead that's taken care of for our overall reaction. That's taken care of in the oxidation already. The other thing we're going to need is some lead oxide. Well, the reduction reaction is going to have to provide that for us because oxidation doesn't. So we've got the first reactant in our reduction reaction, PbO2. So we've got first 2 things in our overall reaction taken care of, the lead and the lead oxide. Now the next thing we're going to have to take care of is 2 hydrogen ions. So my reduction reaction is going to have some hydrogen ions. Now at first you'd think, well, I'll just put down 2 hydrogen ions. But I remembered when I wrote the oxidation reaction out that there was a hydrogen ion here in the product. Now that cancels out that hydrogen ion. So instead of having just 2 hydrogen ions, we're going to need 3 because one of them is going to be canceled out by our product. The net is going to be 2. That's the tricky part. That's what separates the 4s from the 5s. Now, what else are we going to? We're going to need, now we're going to have to deal with the hydrogen sulfate. We need 2 of them. Well, there's 1 here already, so we just need 1 more. Reduction reaction is going to have to include another hydrogen sulfate. A hydrogen sulfate plus a hydrogen sulfate gives us 2. Now let's look here. 2 lead sulfates. That's easy enough. Just add another lead sulfate for this reaction. Give it 1. And then we're going to need 2 waters plus 2 waters. Now, this reduction reaction, because this is a reduction, is going to pull in 2 electrons, and our oxidation is going to release 2 electrons. It's a nicely balanced reaction. Now let me check again. Pb plus PbO2 plus 2 hydrogens, 3 subtracted 1, and 2 HSO4s. Great. The reduction balances the oxidation. 2 lead sulfates, 2 waters, this hydrogen is removed, and this is, I think, the toughest redox question on last year's exam. It's not exactly the same as it, but it's really, really close. That's how we solved finding a missing half reaction. Okay, I didn't even cough too much.